This will be the video for the solubility lab. I'm not going to demonstrate that lab because most of it is just dissolving salt into water, which I think you guys can handle as long as you read and follow those directions. But I will discuss what the data will look like and what we want to calculate in order to answer the post lab for the solubility lab. So you can see I've given a sample entry into the ice water solubility table 1, and in my example the mass of my weighing paper, so when I weighed my weighing paper by itself with nothing on it, I found it to be 3.01 grams. I'll be honest, I don't know why the um, lab has you take this measurement because it's not really used in any of the other calculations, but they do have you take that measurement, so that is what it is. And then I put about 40 grams of salt substitute onto my whey paper, and you can see I actually got a little bit more than 40 grams. I got about 46.34 grams. So that was, a net of about 43, but that's not what really is very important, exactly how much I got on there. I need to know what everything weighed together so that when I got done, after I started to dump the salt into the cold water, I was able to get some of the salt to dissolve, and then finally after some time I was no longer able to get any more salt to dissolve, so I stopped dumping salt off of my whey paper and I reweighed it to see how much I had put into the cold water. And what I found is before I started, I had 46.34 grams of salt and whey paper, and after I finished, I had 35.64 grams of salt and whey paper. So to determine how much of the salt was dissolved in the 8-degree water, I did 46.34 minus 35.64, and the figure I came up with was 10.7. So 10.70 grams of salt dissolved in my 8-degree water. So you've got to do that for 5 different temperatures, and then you will list the amount of salt that is dissolved in each of those solutions and their temperature in the rest of this table. And once you have that data, you should take it over and chart it using a spreadsheet like we've done in many of the other labs. Now, be aware for this one, the way this table is set up is mass of salt substitute dissolved and temperature. So if we wrote it into Excel just like this, mass of salt substitute would be on the x-axis and temperature would be on the y-axis. We do not want that. We want temperature on the x-axis and we want mass of salt substitute dissolved on the y-axis. So when we input them into Excel, we're going to invert this chart basically, and you can see that I've done that here where I have 8 and followed by 10.7, and then the other temperatures 15 and 20 and 20 and 32, and followed by the masses. So then I have temperature in the first column and masses in the second column. That means temperature is going to be on the x-axis and mass is going to be on the y-axis. And so I will plot it like I have done many times already throughout the lab. I will make it show me equation. You do not have to set the intercept equal to 0 for this equation. You can just let it make the best fit line it can and have it spit you out a function. And that function tells you that the value for the y, which is the mass of potassium chloride dissolved, is equal to 1.6813x, or 1.6813 times the value of x, which is the temperature, minus 3.0308. So you can use that equation to answer the questions in the post lab, since mass of KCl is on y. If you wanted to know a temperature at which you could dissolve a certain amount of KCl, you would plug that certain amount in for y, and solving for x would tell you the temperature your solution would need to be in order to dissolve that much. Conversely, if you wanted to know what if you were given a temperature and asked how much could we dissolve at that temperature, you could plug that temperature in for x, and solve for y, and that would tell you how much salt could be dissolved at that temperature. And that should help you answer the post lab for the KCL solubility lab.